So now that we know about parent functions and transformations, we're going to tackle some more challenging domain and range examples. Hopefully also we're going to build a little bit of motivation as to like why we would want to know these things and study these things and how they apply to real life. And also we're going to learn how to tackle some more complicated examples without necessarily needing to look at the graph every single time. In fact, that's our goal here, is to work without a calculator. For this whole module, including the Delta Math, the formative, and your mastery for this will be a no-calc mastery, the very first one of the year probably. And the reason for that is like the being able to think through what a function looks like without having to graph it every time is super important to just building your mathematical intuition. All right, so in this case, we have Mr. Seymour is launching a rocket, and we have a function f of x equals the square root of x minus 30. So this is a square root function. And we're asked to find the domain and the range. And then we have another question B, which we'll worry about here in a second. So how do we find the domain of this without a calculator? Well, we use our knowledge of our parent functions, right? So our parent in this case is square root of x, right? And square root of x, as you will recall, and if you don't recall, you have notes on this, looks like this, right? So it starts at 0, 0, and goes to the right forever. And then our function f of x is the square root of x minus 30. And hopefully you're thinking you already know where this is going, right? So this particular function, right, is a rightward translation of the parent function, okay? So if square root of x looks like this, square root of x minus 30 will just look like the same function shifted to the right. And this point, instead of being 0, 0, will be 30, comma, 0. So our domain and range, well, once we've sketched it, is actually pretty easy. And notice how we didn't need to graph it to figure this out. In fact, it would have been annoying to try to graph this on your calculator because this 30 would put it outside the window, so you'd have to zoom out and scroll around. So knowing how to do this is actually more convenient. My domain, well, instead of being from 0 to infinity, is going to be from 30 to infinity. And 30 is included because when I plug in 30, I get square root of 0, which exists. And my range in this case is going to be the same. My range is going to be from infinity. I can see that pretty clearly based on my sketch. And again, 0 is a y value we can get. And then the question is, how many seconds into class does Mr. Seymour fire the rocket? Well, another way of phrasing this is, when does our function start? And the answer here, of course, is 30 seconds, because that is my domain. So these are the types of questions that domain and range help us to answer when it comes to real-life contexts like this. All right. We're going to consider now a second example about Mr. Seymour's life. In this case, he's becoming a diver. Professional diver is like one of these guys that goes underwater, right? And we have this function f of x that's going to be his depth in feet. And we're asked to find now the range of f of x. Here's the trick, right? I know that f of x is a parabola, and I know it's a happy parabola because my x squared has a positive coefficient. And I'm going to guess that it probably is shaped something like this, right? So I'm guessing it mostly lives in the positive region of the x-axis, and I'm going to guess that it's below 0 because my depths are negative. But I don't know to figure out my range. I need to find this point, right? I need to find the vertex. And I don't know what it is, right? Based on how this is written. This function f of x is not written in a nice way for me. So my move here, in this case, I want to rewrite this in vertex form. And the way we do that, you did this in Algebra 2 by completing the square. And I will show you this algebraic work. Hopefully this seems familiar. I like to subtract that constant term to the left, and then I need to add b over 2, so 120 over 2 squared, which is 3600 to both sides. And this is called completing the square. I picked this number because it's going to factor nicely. So this, of course, gets me f of x plus 100 on the left and x squared minus 120x plus 3600 on the right. And here's where I can factor now because I picked the correct number. This factors to x minus 60 times x minus 60 or x minus 60 squared. And then I can subtract that 100 back over. So I'll get f of x equals x minus 60 squared minus 100. Okay, so sometimes we need to rewrite these things in order to get it into that nice vertex form and figure out what transformation is happening. So notice we have now minus 60 minus 100. What that means, right, is my vertex is at 60 seconds. He is at a depth of 100 feet, right? Negative 100 is my y value. Okay. And remember, we were asked to find the range. So my range, well, negative 100 is my minimum. And technically, my range is infinity, although that doesn't really make a whole lot of sense in my diving context, right? He's never going to reach a height of infinity. But he'll probably reach a depth of negative 100. That's my minimum. And that's a super useful thing to know if you're Mr. Seymour the diver. Okay, so notice we can use our knowledge of transformations to figure out domains and range. And the last thing I'm going to point out here is that we don't even need to know what the function is. So reading this one, we see that h has a given domain and range, and then we have this transformation of h. We have h of x minus 5, and then outside the parentheses plus 12. Well, you know now from your work that this is a shift to the right 5, and 12 is a shift up 12. So to the right 5 is obviously going to change my domain, my new domain. Well, if I'm shifting to the right 5 and my leftmost point before was 5, my new one's going to be 10. Infinity we don't need to change, right? Because shifting to the right is not going to move a graph going off to the right forever any. And then my range, well, if I'm going up 12, I have two numbers I'm going to change here. My range is going to be now 19. I'm adding 12. And then, so once I understand this logic, I don't even care really what h is, and I can still figure out domains and ranges of a changed version of h.